Welcome to my video lecture based on starting methods and types of single phase induction motor. In my previous lecture, we have highlighted several methodologies like how the single phase induction motor is started and why it is not self-starting. In whose principle it explains that why it is not self-starting, double revolving field theory, cross field theory, and based on double revolving field theory, how the field of the induction motor in backward field and forward field, torque representation, and how the torque speed characteristic is actually made, and what is the equivalent circuit of single phase induction motor, performance characteristics, monophase, proper phase, testing of single phase induction motor. Those things we have also studied or learned in the previous lectures. In this lecture, we will see that how the single phase induction motor can be started with various methodologies, and based on that, different types of motor can be divided. That means the types of the single phase induction motor are basically based on their starting method. Myself, Purvian Banerjee, Assistant Professor of Electrical Engineering Department, Dr. Sudhir Chandrashur, Degree Engineering College. In this lecture, we will see that how the single phase induction motor can be of different types, and mainly I will discuss about a particular type single phase induction motor in this lecture. So we will start with our lecture, that is starting methods and type of single phase induction motor. We have seen that some means should be used to start the single phase induction motor, because single phase induction motor is not self-starting. Basically, single phase induction motor is not self-starting. So definitely it needs some means to start. So based on this single phase induction motor can be different types. Okay. Now, therefore, mechanical methods are here impractical. It is not possible to give all the time external force to the motor to start. So, electrical methods are taken for starting the single phase induction motor. So, in the single phase induction motor are classified according to its auxiliary means to start, which are used to start the motor. Auxiliary means can be capacitor, it can be resistor, it can be inductive type. Various methods are there, which we will learn in step by step. And based on that, mainly 5 types of single phase induction motor are classified. First one, split phase induction motor. Second one, capacitor start motor. Third one, capacitor start, capacitor run motor, or it is also said 2-valve capacitor motor. Fourth one, permanent split capacitor type or single valve capacitor motor. And fifth one, shaded pole motor. So these 5 types of single phase induction motors are generally classified as like this. So in this total lecture, we will mainly highlight on the first type, that is split phase induction motor, and how this split phase induction motor is actually made, and how its torque speed characteristics, and what are the basic phenomena it has been taken, those things we will see. Split phase induction motor. We know that single phase induction motor is not self-starting, and we know that to start a motor we definitely need minimum 2 number of phases. That means we have to split that phase. So this type of motor is known as split phase induction motor. We are just splitting the single phase and making it two phase to start the motor. So it is split phase induction motor. So how we are splitting the phase, that we will see now. Then this is the single phase supply, that means 220 volt supply is given here and current is flowing through this way. Now this is the main winding of the motor, and in parallel to that a centrifugal switch is connected, and then via centrifugal switch some resistor and some inductor are connected to it, and it is written as starting winding and auxiliary winding. That means via the centrifugal switch another resistance and inductance is connected with this main winding of the single phase induction motor. Now the question is how we can split the phase. That means when we are taking two currents in parallel branches, that means the two currents which is flowing, one through main branch, that is IM, and when the centrifugal switch is closed, then another current will flow through the auxiliary branch, that is IA. And if the phase difference between these two currents are different, then we can create the split phase or two phase. Right? So how this phase difference can be possible? We know that the voltage current relationship for a pure resistor, it is voltage and current are in same axis. If the circuit is purely inductive, then current will lag by 90 degree, and if it is purely capacitive, then current will lead the voltage by 90 degree. In that way, that means by changing the variation of inductive effect, we can vary the phase. So here that phenomenon is taken into account to split the phase. So it is in this type of motor is also called as resistance start motor. Here we don't use any capacitor, only we have connected some resistance and some inductor is here, and variation of the values of inductive effect and resistive effect, it will create the effect of phase difference. So how this is possible, now I am telling you. Here in single phase induction motor, two windings are present, main winding and starting winding. This is main winding, this one. So this one is our main winding and this is the auxiliary winding. In main winding, some resistance and some inductance is present. Main winding resistance is Rm and auxiliary main winding reactance is Xm. And auxiliary winding resistance is Ra and auxiliary winding reactance is Xm. And the value of Ra and Xa will be such that the ratio of Ra and Xa should be always greater than the ratio of main winding resistance to main winding reactance. That means in case of main winding, the value of resistance is low and the value of inductive reactance is high. That means the value of resistance is low in case of main winding and the value of inductive reactance is high in case of main winding. And just reverse will be in the auxiliary winding. That means the value of resistance is high and value of inductive effect or inductive reactance is low. So if this persists, that means the ratio of Ra by Xm, they must be greater than the ratio of Rm by Xm. So definitely in this way, the phase difference of nearby 90 degrees in space is created and it creates the two-phase induction motor. Now, the current Im in the main winding lags behind the supply voltage V by 90 degrees. Why? Because we have seen that in case of main winding, the reactive value or inductive reactive value is high. That means the main winding is much more inductive. So definitely the main winding current will much more lag. That means nearby 90 degree lagging to voltage. And in auxiliary winding, as the resistive part is high, that means in auxiliary winding, the current will be just near about phase with voltage. That means now we have got two currents. One current is nearby 90 degree lagging and another current is almost 0 degree. That means we have two currents which are almost 90 degree in phase difference. This created. But usually the time difference of phi is not 90 degree but in order of 30 degree, because the inductive effect and resistive effect that cannot create such kind of huge phase difference of like 90 degree. It is near about 30 degree it can create. The phase difference is enough to produce the rotating magnetic field, and this 30 degree phase difference is also sufficient to create the rotating magnetic field, because we have two currents with two different phases, and wherever there is two phases, minimum of two phases, and it can create the rotational field. So it is sufficient to give the motion so that it can start it. Since the current in the two windings are not equal, the rotating field will be not uniform. In this case, as these currents are not equal, so the field which is created, definitely it is rotating in nature, but it will be not uniform. Okay, it is not uniform. And the starting torque is also small, near about 1.5 to 2 times of the rated running torque. The main and auxiliary windings are connected in parallel during the starting, and the starting winding is disconnected from supply automatically when the motor reaches the speed about 70% to 80% of the synchronous speed. Okay. For the motor rated about 100 watt or more, a centrifugally operated switch is used to disconnect the starting winding. In the diagram, we have shown a centrifugal switch, this one. When the motor rating is about more than 100 watt, then we are using centrifugally operated switch, which is used to disconnect the starting winding. For smaller motor, generally relays are used. When the motor size is less than 100 watt, maybe for 5 watt or 10 watt, maybe 50 watt, then relays are generally used. The relays are connected in series with the main winding. At the time of starting, a heavy current flows in the relay coil, causing its contacts to close. Okay. This brings the starting winding into the circuit. As the motor reaches its predetermined speed of order 70 to 80% of synchronous speed, the current through the relay coil decreases, and consequently the relay opens and disconnects the auxiliary winding from main supply, and the motor then runs only on the main winding, and the torque speed characteristics now I will show. So the first thing which we have already said, that the current in main winding that is inductive in nature, so it will lag near about 90 degrees than voltage. This is the main winding current. And the auxiliary winding is much more resistive, so it will be near about 0 degree of near about 0 degree in phase with voltage. But as this is not purely resistive or not purely inductive, so definitely these angles are not 90 degree and this angle is not 0 degree. And the resultant one of these two, IA and IM, this is I, which is just near about 30 degree in phase difference between the two. Okay. So that much of phase difference is created here in case of split phase induction motor, and due to the unequal amount of field production, the rotating magnetic field which is created, that is non-uniform in nature. Okay. And the main thing we will see that the amount of torque split characteristics. So when the main winding and auxiliary winding both are connected, at that case the maximum torque, it will be reaches here. Okay. And when we are just omitting the auxiliary winding from this point, then only by main winding the motor is running. And as for this case, the effect of auxiliary winding is very less. So here the effect of torque which is created due to main winding plus auxiliary winding, that is also less. So when we are removing the auxiliary winding, the motor maximum torque expression is just almost similar than auxiliary winding plus main winding torque is almost equal. So there is almost no effect. So this is the torque split characteristics of split phase type induction motor, and this one is the phasor diagram for split phase induction motors. Split phase induction motors are generally used in case of mixer grinder, for any kind of small size motors where the rotation is needed, small type fans, and where the uniform speed is not much more our concern point. There we are using split phase motor because it is very cheap and its costing is very less. So this kind of motors are generally used for small size motors, and it is for cheap purposes. That means where quality is not much concerned, only the speed creation is sufficient, there we can use this kind of motor. So up to this much for today, and in my next lecture we will see how the capacitor start motor are used and how the capacitor will improve this kind of problem, which is in split phase type of induction motor, and how the phase difference can be improved when we are connecting capacitor to it. Then much more better speed difference or much more better uniform fields can be created. That's things we will see in my next lecture. And we will see that how single phase induction motor can be done with different kinds of mechanism, and how the torque characteristics are also changed with the effect of this auxiliary wheels, and that part we will see. So thank you up to this much for today. Thank you for listening my lecture.